Right, since the last video I've been looking into the possibility of creating bootable double density disks from simple disk image files, and I suppose the obvious question is why. It may well be that you get hold of an MDS and you've got no boot disk. Then of course you've got a bit of a problem on your hands. The other scenario is, of course, even more disappointing, is that you get a nice disk with your machine and it doesn't work. Clearly the disks tend to degrade over time, and worse still is that the magnetic material that's deposited on the substrate of the floppy can actually strip off the surface. And if that happens, you're in real trouble. Certainly if you ever insert a floppy and hear a sharp pitched squealing noise, then take it out immediately, because that's probably what's happening. It's very, very difficult to get it off the head after that happens. I mean, it's not impossible, but it is a right pain in the backside. I mean, other reasons are, you may just want to try a different version of the operating system than the boot disk that you have. So it gives you a bit more flexibility. The current program that I've written, it takes about 7 minutes to write a floppy, so it compares to a lot of things. Even sort of transferring all those single files probably would have taken you more than 7 minutes. So got a few applications. Right, well, before we look at the program, let's just look at the various disk formats there have been over the years. The first of these was the single density offering, and that's this disk here. That's designated by blue label by Intel as being single density. That disk had 77 tracks, 26 sectors per track, 128 bytes per sector, and it used an FM recording method, and that gave you about 256K. Now, this format was common-ish in the day, and it's probably possible, well, it is possible to actually recreate one of these disks. The only problem with it is you've got to find a floppy disk controller or a motherboard with a floppy disk controller on it that will actually produce this format, and you need a 5¼ inch to 8 inch adapter, of course. So it's a bit of a pain, but it's doable if you got really stuck. The second iteration was the double density version, which is much the same, but it's got 52 sectors per track rather than the 26. So that gives us now 512K on the disk. Now that's all very well, but unfortunately the method that Intel decided to use to produce those extra sectors was something called an encoding method, I should say, called MMFM, or M2FM for short. Now that particular encoding method was only adopted by very, very few companies, and as a result there's nothing that's available today that can create that format. So creating one of these disks other than using an MDS is nigh on impossible. That's another reason for trying to get this program to work. Right, so let's have a little look at how the program should work. So let me get the floppy out of the way. Right, so here's my simplified floppy disk. It's very simplified because it's only got one track and it's only got 10 sectors. The sectors are numbered 1 to 10 on this inner ring here, and we'll call that the physical sector numbering. Now, it's quite easy to get hold of .img files, and they're very simple as well. This is my diagram of an img file, and all it is that you get 128 bytes in the first sector, then that's followed by 128 bytes for the second sector, and so on. So it's really, really simple. So all we need to do is find a way of getting this over there, and we could just write this 1 to 10, so we go around there, and that'd work. There is a bit of a problem though. If you do that, the results are going to be very, very slow. The reason being is that if we assume that the top of the pen there is the head, that the system will read the data out of sector 1 okay, but then of course it's got to process that data. But unfortunately, of course, the disk is continuously rotating. It's not going to stop. And a machine back from 1977 or the 1980s wasn't very quick. And it's highly likely that by the time it's ready to read sector 2, it'll be over here. Which then means it's got to take almost an entire rotation before it gets to sector 2 over here. That's why you lose speed. Now, back in the day, it was quite common for disks to have something called skew. Now, how skew works is that we take the normal physical layout here, the 1 to 10, and then we logically renumber the sectors. So on this, I've used a skew of 3, which I've used in the program, which seems to work okay. I'm not sure if it's the right figure or not, but hell, it works. So what happens is we do 1, 2, 3, and we write sector 2, and then we do 1, 2, 3, and we do sector 3, and we do 1, 2, 3, and then we go to sector 4, and it just goes on like that. So all that we've done is that we tell our formatting program is that whilst it's doing the formatting, is that it labels every third sector the next logical sector, and then in doing that, the program can read sector 1, the disk can continue to rotate, and hopefully by around here it would have finished processing and it'll be ready to read sector 2. So that's the theory anyway. So we'll pop over to the MDS and I shall show you how it works. Right, the program itself's based on an idea by Mike Douglas. He had a program called PC to Flop, and if you look back through my Altair videos, you'll see me demonstrate that. And basically what it does, it downloads all the data over Xmodem on the serial link, and then the Altair writes the disk, and that's exactly what we're going to try and do here. I've booted up the MDS 800, reassigned the CRT as usual. This program should work on an MDS2 and MDS3. However, what you're seeing on boot up obviously will be your actual CRT, because it's got a built-in screen on the MDS2 and 3. So what you'll need to do is connect up to the serial port around the back. I think it's serial 2. And then reassign your console to the serial port. Then you should be able to carry on as we are here. Right, so the first thing we need to do is to find some way of getting a program on there, because all we've got is the monitor. So what we're going to do, we're going to put a little bootstrap program in. So we'll just go around this side. Okay. So what I've done, I've provided this little bootstrap, which is fairly simple. It just takes sort of single bytes from the serial port and sticks them into memory. Right, so we'll put that in first. It resides at 3000 hex, so we'll do S3000, and then we'll put the bootstrap in byte by byte. So it's 21 00 20 11 A7 01 DB F7 0F 0F D2 06 30 DB F6 77 23 1B 7A 83 C2 06 30 C3 00 20. Right, let's display that out. D3000 3019. Hopefully that's our bootstrap in. Let me just have a quick look at my little bit of paper here. Let's send one. That looks reasonable. 3. Yeah, that looks like it'll probably work. Right, we'll run that. So we'll do go 3000. Bootstrap's running. We'll send down the file. So we'll do send file. Find the files. Okay. There. Down. Right, so what we're going to send it is hexload.bin. So I'll do that. Make sure that binary tick is ticked. We'll click open. Right, there we go. That seems to have been successful. We're now running the hex loader program. So we've now got a method for actually getting stuff onto the machine. What we're going to do, we're going to load 2 programs. We're going to run one that will speed up the serial and the actual program itself. So we type H, and I'm going to send the first one, which is rs232.hex. If you've got an MDS2, you'll need to send this. Oh, sorry. Scroll down a bit. You'll need to send that one, the rs232-2.hex. I think that works because I copied it straight out of the Intel manual, so if it doesn't work, blame Intel. Right, so let's send that one down. That one's in memory. We'll do hex load again and send down the program. Right, the program is img2mds, so we'll send that down. Right, that's it. Both the programs are in memory, so we'll exit out the loader. Currently, we're only running at 4800 baud, so that's fairly slow. So we're going to speed that up by changing the the multiplier rate or division rate in the user. So if I run that's 1000, what this will do, it will change the division rate from 64 to 16, so it should make it 4 times faster. Right, there we go. So we need to change our serial baud rate, so we now go up to 19200. Okay, hit return. Right, we're running much faster now, so we're running at 19200, as you can see at the top here. Right, now the next thing to do is to run our program, which resides at 4000 hex, so we'll do go 4000. Right, that's it, our program is in memory. We've now got an option of which drive we want to do the imaging in, and we can just quit. So let me get a floppy over. Okay, I'll decide to use F:0, so I'll type 1. Now it's waiting for me to put the floppy disk in, so I'll get the floppy disk, pop that in the drive, and as soon as I close the drive, it's recognised the disk's in there. Now what I'll do, I'll just scroll the camera down and over so you can see the formatting operation. So right, here we go. I'll answer yes to format, and you can see the head moving across and formatting the disk. If you're using a completely unused disk, you will need to format it. I mean, there may be other reasons that you might not want to format the disk. If you're running this at a later stage where you've got ready formatted ISIS disks, then you can skip that step. And also, of course, I'm not entirely sure about the skew rate, so you may want to use a proper ISIS skewed disk. Right, so we'll scroll back up again. There we go. Right, it's now asking us to send the image file using Xmodem. So what we'll do now is pick up our image file. So we'll do file. This time we're going to do transfer. We're going to use Xmodem and we're going to use send. And I'm going to use this image here, which is a image of a ISIS 4.1 disk. Just make sure that little tick there says checksum. Right, okay, click open. Right, it'll start downloading data, about 6.5k, it'll start writing to the disk. You probably heard the clonk in the background there, and it'll do a little bit more. And every 6.5k it will write another track. So what it's doing, it's going track by track. If I just scroll the camera down again so you can see it working its way across the disk. Right, if you keep an eye on the head, each time it gobbles up some data, it'll go out a little bit further. So it'll do this 77 times. I'm going to try and optimize that so it writes probably about four tracks at a time. I don't want to go too far because I want to make sure that this program will still run on a 32k machine, because it is possible to run ISIS on a 32k machine, although it's probably not recommended. Right, okay, so this is going to take about 7 minutes. So what we'll do in the meantime, we'll have a look at a few other bits and pieces. Let me go back to the screen. Right, what I'm using here, I'm using Teraterm. You can download that quite easily. This version I downloaded off of Mike Douglas's site, deramp.com. I'll try and put a link in the description. Initially what I'll be supplying is from my little Google Drive. I'll supply these files. I'll supply the bootloader, the bin file for the hex loader, the hex file for img2mds, and the 2 variants of RS-232. I'll also supply the source for the RS-232-2 just in case it's wrong. I will try and get someone to try it on an MDS2, and I'll do a follow-up video. And as I improve the program, I'll probably do some update videos, and I'll upload the new versions. I will be supplying the source at some point. Not right at the moment because I'm still tidying it up. We can have a quick look at the source while it's still grinding about. I've got it here somewhere. Where is it? It's in the other window, I think. Right, this is the source. Program's a bit of a mixture. As I've noted in the credits at the top here, the Xmodem program actually doesn't come from PC to flop. It actually comes from PC get. But Mike Douglas actually copied that from somewhere else. Some of the diskette write code comes from Richard Main's USB upload program. Most of it's been redone and recommented though, so just to credit those people. The rest of the integration of the program and the format routine and all the rest of it I've done from scratch. So if we sort of scroll through the program, just have a quick look at it. Just a few equates and stuff at the top, nothing obvious, nothing too complicated, I should say. There's an option here to use a second serial. That's not implemented yet. So this is the bit where it requests which drive you want to use. If we carry on, here it's generating the drive error bit code. Just in case there's an error, it needs to figure out what it is. That's what that does. This bit here checks whether the user has put the disk in the drive. If it's already in there, it just carries straight into the format routine. This bit is asking, do you want the disk formatted? So that's fairly straightforward. If you decide you want it formatted, it carries on down here. Now, at this point, it branches out to a subroutine which does the formatting, so we can go down there, have a little look. Oops. a bit too far there, I think. Right, so subroutines, here we go, format floppy. This is the formatting sequence for the floppy. Now you'll notice it does an LXIH to interleave. That's where we get the interleaving from, and there's a little table at the bottom here. And if you look at it, you'll see the first digit is where it works out of the interleave. So it's going sort of sector 1, sector 36, then 19, then 2. So we've got the sort of 3 to 1 hop again. So we've got 1, 2, 3, then sector 2, and then 1, 2, 3, then sector 3. Let's just see how the imaging is getting on. Right, we're doing quite well. We're up about 76% now. We're getting there. Right, so let me go back a little bit. There's also, I can't go over this in real detail. We're only having a sort of quick look here, but there's an error handler there. This is the bit where it writes a track. Basically what happens is the Xmodem program downloads a track's worth of data, so about 6.5K, then the floppy controller actually writes an entire track to the disk, and it just goes around in circles basically. So that's a rough idea what the program's doing. How are we doing? Up to 87%, we're doing quite well. The sources of the img files, best one is Bill Beech's site here. You can see he's got all sorts here, from ISIS 3.4 right up to 4.3, and even CPM. I'll actually show you one of those in a minute. There's also some on Bitsavers as well. I'll put a link into both of these. Right, so let's go back to the program, see how it's getting on. We're getting very close to the end now. So we'll just watch the last few bytes go over to the disk. About one more read might do it. Oh no, one more. Here we go. Right, this should be the last read. There we go. It's come up and it says imaging complete. Brilliant. Now, you need to be a little bit careful at this point, because don't forget we've actually altered the baud rate. When we reboot the machine, of course, it'll go back to 4800 baud. So let's change that now, so we don't get down into a bit of a problem. So we'll go back to serial port again, and we'll go down to 4800. There we go. Right. So what I'll do, I'll reboot the MDS. What shall I do? I'll move the camera down a bit, so you can probably see the screen and you can see the floppy. Right, so I hit the boot switch, hit reset, drive's gone back, hit space, release the boot switch. There you go. So there we go. That's ISIS 4.1 from basically just a really simple image file. I'll do a directory. There you go. Can't really see much. Let me do a dir on the invisible files as well. So there you go. I mean, this is working on a 1 to 3 interleave, and it seems pretty quick. And I've actually done some timing on an original ISIS disk, and I think this is faster. So kind of odd. So let me just try running something. There we go. I'll try copying a file. BSM80 to BSM80, say. Oh, I've got that wrong, haven't I? I should have done 2 BSM80. Okay, tries copying away, and now I can run BSM80. So there you go. The machine's got no idea that that's not a genuine ISIS disk, really. So there you go. I've tried so far ISIS 4.1 and 4.2, I think. I'll show you the CPM one I did as well. Let me just eject that disk. There we go. Let's get out of the way. Right, pop that in there. Right, do the same thing again, hit boot switch, hit reset, hit spacebar, lose the boot switch. So there you go, CPM. Do a quick directory on it. So as you see, I mean, in theory it should be able to create any Img format disk. I don't see why it shouldn't. Bear in mind this is only for double density disks at this stage. I've not got a single density machine, so I can't really carry on any further than that. Might do a follow-up video on the CPM because I've copied a few other things on here which might be interesting. So that's it then. So if anyone wants to give it a try, the files will be on the Google Drive, and I will post some follow-up videos. So that'll do it for this one. Hope you've enjoyed it, and I shall see you next time.